Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we are going to continue about chapter 12.2, Viscosity, from the book Shigley Mechanical Engineering Design. Okay, all the pictures is taken from the book itself and also from Google Images. So let's continue. Okay, uh, the deck of cards. Uh, this book give example of the deck of cards. Okay, you can read all this statement. This statement represent what is the difference between falling of a deck of card and falling of a normal structure. Okay, this is a normal structure. Okay, when you fall down, it fall down like this. It, okay, this is the normal structure. If it fall down like this. Okay, but the deck of card, you see here, this is a deck of card. When you fall down, it will go fall down gradually. Okay, front first, then gradually going down. You can imagine that. Okay, you can imagine how the deck of cards fall down. Okay, so figure 12.21, we will see in the next slide. Here is the figure 12.1. Okay, 12.1 shows like a deck of card falling. Okay, the book wants to resemble how viscosity happen. Okay, you can see here the force, the U, the A, the H, the V, and no, the Y, and micro mu. Okay, what does it mean by this? Okay, now viscosity happen. T tau is the shear stress. Force is the force. A is the area. Okay, U is the what? Velocity in this. Velocity. U is here. This is U. It is viscosity of the slip. And then U here, capital U, is the viscosity of the journal. Okay, and Y is the any point here between the viscosity up until the journal, and H is the height of the journal. Okay, let me explain better. How can I um, imagine? Okay, imagine you make you put a piece of paper on a water. Okay, this is a piece of paper on water. Okay, this is water. Okay, the piece of paper is floating on the water. Okay, this piece of paper is floating. Distance between the bottom of your container until the piece of paper is H. Okay, distance between the piece of paper and the water container is H. Okay, at any point between the bottom of container until the piece of paper is Y. Okay, and then when the water flow, okay, when the water flowing from this point to point A to point B, it is U, because U is the velocity of the water underwater, under the paper. Okay, force is when you push with your hand the water, the paper. When you push with your hand the paper will go in front. Okay, it is like it is the force. And U, the capital U, is the velocity of the paper traveling. velocity of the paper, not velocity of the water. The water is u, small u. Okay, u. U here is the velocity of the paper traveling, and A is the area of the piece of paper. Okay, okay. For a general bearing, okay, for a general bearing, if you understand this resembling of paper, paper on the water container, uh, I will try to explain about the general bearing itself. Okay, the general bearing. This is the shaft. This is the container of the general bearing. Okay, and this is the general. The H is so small. Theoretically, you can see with your eye because it is so small. Okay, the H, because the distance between the journal and the bottle container is so small. It is get by the oil and by the grease and everything. So but the theory is the same. Okay, the height, the u is the velocity of the journal itself, and the u here is the velocity of the oil of the grease. Okay, the capital U is the velocity of the journal when it's rotate, and u, small u here, is the velocity of the grease traveling inside the journal. Okay, try to understand that. Okay, so rate of shear when m is a constant proportionality and defines absolute viscosity called dynamic viscosity. The derivative du per dy is the rate of change of velocity with distance and may be called the rate of shear or the velocity gradient. Okay, and viscosity m is a measure of internal frictional resistance of the fluid for most lubricating fluid. The rate of shear is constant and du per dy is equals to u per h. Like just I explained uh, before this. Okay, fluids exhibiting the characteristic are said to be Newtonian fluids. Okay, the unit of viscosity of IPS system is can be seen in pound force per square inch. This same as stress and pressure multiplied by time. The IPS unit is called Ren, REYN, Ren, in honor of Sir Osborne Reynolds. This is the picture of Sir Osborne Reynolds. You may learn this in your subject fluid mechanics and everything. Okay, so this is how the formula happen. It, stress equals to force over area equals to mu u per h. Okay, this is absolute viscosity. Is measured by the Pascal second PA dot S in SI. It's the same as Newton second per square meter. This conversion from IPS unit to SI is the same as for stress. For example, multiply the absolute viscosity range by 6890 to convert the units of PA dot S. Okay, the unit conversion you must convert to 6890. Okay, this is the conversion unit. You will find it when we are doing some calculation after this in the next video and everything. Okay, so unit by ASME. ASME is American Society of Mechanical Engineers. ASME has published a list of CJS unit that are not to be used in ASME document because it is historically used, but now the modern standard and everything we don't use. Okay, anymore. Okay, we don't use this kind of units anymore. Okay, previous generation they use this unit. Now we are living in the new generation, we don't use this unit. Okay, you can find this book does not mention the name of the unit. You can find it by yourself. Okay, this result from a combination by International Committee of Weight and Measures (CIPM). The use of CGS unit, special names are discouraged. Okay, included in this list of unit of force called dyne, unit of dynamic viscosity called poise, unit uh, kinetic viscosity called stoke. Okay, All these units has been and still are used extensively in lubrication studies. Okay, so because it is historically used, we still use it. Okay, but officially does not use anymore in proper document. But if you are dealing with a senior technician, senior engineer, they may use the old unit. Okay, okay, we respect them, no problem. Okay, as long as we know how to convert, we know how to calculate, is no problem with us. Yeah. Okay, the points in CGS unit dynamic of solid viscosity, and unit is uh, 9 per square diameter. Okay, customary to use inside the points CP in analysis because the value is more convenient. Okay, the conversion from CGS to SI LPS unit is as follow. This is the conversion: 6.89 U rand. Okay, using IPS unit, micro rand is more convenient. Symbol U will be used to designate viscosity. U is equal to U 10 power of 6. Okay, so this is the unit. We will use this when we are doing the calculation. Okay, this is the Sebok Universal Viscometer. This picture is I take from Google Image. Okay, you can find better picture in Google Images. You just type Cyborg Universal Viscometer. This is the function is to find uh, the viscosity. Okay, ASTM standard for determining viscosity uses instrument called Cyborg Universal Viscometer. Just Google it. This one for you want to know what is the um, image was in the diagram, how the cyborg viscometer, how it is operational. Okay, so the zk equals to 0.22 t minus 180 over t. So the t is in stethoscope, t is the number of second on cyborg. And this is the kinematic viscosity. Unit have square per meter per second. This is the unit. So v equals to this over dynamic viscosity, we multiply V by density, and you get this unit, okay, where U is Pascal second. And the last slide shows the comparison of viscosities in various fluids. You can see here water that we drink, okay, has low viscosity, okay, and then gasoline, no, uh, the air is low viscosity, the gasoline has viscosity, the water, gasoline, the castor oil, SAE oil. It is uh, this is the oil that you use in your car when you are servicing your car. 10,000 kilometer, 5,000 kilometer service. This is the oil that you use. Okay, SAE castor oil and many other oils. Just give example of viscosity of fluid so that you can know. Okay, so that's all for the video. Okay, we are going to continue in the next video on Petrov equation. Thank you very much.